Hello, thank you for joining us today for our webinar on the impact of insulation chemistry on surface corrosion. My name is Patrick Farrell, and I will be your moderator today. Before we get started with our actual presentation, there are a couple of logistical things we would like to cover. First and foremost, a little bit of a disclaimer. The information provided in this webinar is not to be used as a substitute for professional engineering design and/or documentation required by building codes, contract, or applicable laws. And also, please refer to our manufacturer specification, application guides, instructions, and guarantee requirements on all the projects that you may be working on. Next, questions today. If you have any questions, in the bottom right-hand corner of your screen, there is a button for questions. All the questions will be submitted via the questions box. And at the end of the webinar, we will leave some time to answer as many questions as we can. Anything that we can't answer today, we will get back to you via email to answer on a one-to-one basis. Second thing, technical difficulties. If we have an issue, WebEx drops, phone line problems, we will pause the webinar for 5 minutes to address those problems, and at that time make a call if we can continue the webinar or if we need to reschedule or send you a virtual on-demand version of it. And then the next thing is a survey. At the end of the webinar, you will see an automated survey with some questions and comments and concerns you may have. We'd love suggestions you have. We'd love some comments you have. We'd like to know what you'd like to learn about the future, or if you want to hear from our team about a lunch and learn or a specific project that you're working on. And then the last thing is we also get asked quite often if we send out the deck after the webinar. And while we don't send out the deck, we do send out a video recording next week for the webinar itself, so you can actually watch the video in context with our presenters today. So keep an eye out for that next week via email. If you don't get it, you're more than welcome to reach out to us, and we'll make sure you do get it. Outside of that, I'm going to turn it over now to our presenters, and I'm going to let them introduce themselves. Thank you very much.
All right. So my name is Mary Beth Jones. I'm a product engineer with Johns Manville. I've been with JM for about 9 years. The last 4 of those have been supporting our industrial insulation businesses, specifically the technical product support and new product development on our calcium silicate, perlite, and our metal and foam businesses. Scott?
Thank you, Mary Beth. My name is Scott Sinclair. I am the National Specification Manager for our Industrial Insulation Group. I've been with JM a little over 2 years now, but have been working in the industrial insulation field for about 17. And I happen to have a bachelor's degree in electrical engineering, but find the insulation field much more interesting.
Thank you, guys. And now we're going to turn it over to Scott, and we'll get started with our presentation. Again, if you have any questions, please feel free to put them into the Q&A box in the bottom right-hand corner of your screen.
All right. Thank you, Patrick. And we'll go ahead and get started. Before we dive into the meat of the presentation, just a little bit of introduction and probably overview for some of you. Take a little bit of a discussion and look at corrosion under insulation and why this is such an important topic for our industry. The National Association of Corrosion Engineers, or NACE, published a study in 2013 called their Impact Study, where they analyzed the financial impact of corrosion under insulation. And they estimated through that study that the global cost of corrosion was about $2.5 trillion. And in addition to that study that NACE performed, many of the major manufacturers or producers or operators in the industrial sector, the large oil and gas, chemical, petrochemical companies, have reported and estimated that between 40 and 60% of the money that they spend each year on piping and equipment maintenance in their facilities is being spent to address and mitigate corrosion under insulation issues. So obviously you can see that this is financially a very significant issue, and one that should be top of mind for pretty much anybody who is designing and specifying insulation systems. If you drill down a little bit on that report that was published by NACE, They go into quite a bit of detail looking at the information across different sectors of the economy as well as different geographic regions, and break it down into quite a bit of detail. For the reference for most of us on the call today, if you take a look at the box outlined in the yellow or gold, that is just the industrial insulation sector in the US alone. And you can see that for the information they gathered in their study, that accounted for a little over $300 billion in cost to the US economy. So once again, the financial impact of corrosion under insulation is very significant and should be something that is high on everybody's priority lists. And again, before we get into the actual details of our discussion today on corrosion inhibitors and insulation chemistry and how that can impact corrosion under insulation, let's take a little bit higher level view of considerations that you should keep in mind when you are looking at what you can do to try and mitigate corrosion under insulation or reduce the opportunity for it to occur. And it really is and should be a complete system approach, starting at the very beginning during the initial system design phase, making sure that you are taking into account all the issues related to things that can cause or accentuate the opportunity for corrosion to occur, as well as looking at risk-based factors in terms of areas of a facility that might be at higher risk than other areas due to various environmental or physical or operating conditions for that facility. Then when you look at the pipe or equipment that is being insulated, it's important to look at the complete system and not just the insulation material itself. Starting with the steel pipe or piece of equipment involved and understanding what is the base metal. Is it carbon steel? Is it stainless steel? Because each of those will have different types of corrosion mechanisms that would need to be addressed. And then looking at whether or not you should have a coating on the outside of the metal to provide an extra level of protection. That can play in very strongly with the risk-based assessments that you might do. Then a newer technology that is starting to get a lot of interest and focus these days is the inclusion of spacer systems in the insulation. And those spacer systems can be either between the pipe and the insulation or between the insulation and the outer jacketing. Then you would have the insulation system itself and looking at the insulation material. Whether or not having a water resistant or hydrophobic material is integral to your strategy. And then, as we will be discussing in much more detail today, looking at corrosion inhibitors that would be integral to the insulation material. And then obviously looking at the jacket itself and picking the most appropriate jacket material, aluminum, stainless, steel, depending on what risk exposure there may be for the jacketing in that system. And then crucially important to any insulation system is making sure that you establish and execute an effective inspection and maintenance program. Insulation systems are not an install it and forget about it system. They do require inspection and maintenance to make sure that they can continue to operate at their peak performance levels. And with that, I'll turn it over to Mary Beth, and she will start talking about some of the studies we have done to analyze the impact of corrosion inhibitors.
So as he's mentioned, the study we're going to be reviewing today is on the use of corrosion inhibitors in an insulation system. So to start with, what is a corrosion inhibitor? So a corrosion inhibitor is a chemical compound when added to a liquid or gas, decreases the corrosion rate of a material, typically a metal or an alloy, that comes into contact with a fluid. A common mechanism for inhibiting corrosion involves the formation of a coating, often a passivation layer, which prevents access of the corrosive substance to the metal surface. So while Scott already covered the cost of CUI, it's also important to understand the value of insulation. Industry continues to insulate pipes, tanks, and vessels, even with the known risks of corrosion under insulation. And that's because of the overwhelming benefits to energy efficiency, process control, personnel protection, and even in some cases, fire protection. So while the benefits continue to outweigh the risks, continuous improvement in mitigating that risk is essential. And again, as Scott has covered what that total system looks like today, we're just going to be highlighting the use of corrosion inhibitors in the insulation. Can they improve the life of the piping system by reducing CUI? And then how long can they be effective? So in this analysis, we use the ASTM C1617 corrosion test protocol to look at the corrosion surface layer of typical industrial installations, some with and some without corrosion inhibitors. The materials that we looked at were the JM's Thermo 1200, the JM Sproul WR 1200, JM Minwell 1200, JM Insulthin HT, and then also a Silica aerogel blanket. The analysis techniques that we use were EDS, optical microscopy, and SEM analysis. So let's review a bit more each of these installations that were tested in our experiment because they're all very different. Thermo 1200 is a calcium silicate-based installation. It's rigid with a high compressive and flexural strength. It excels in high abuse-prone areas. Unlike the rest of the installations that were tested, it's not considered hydrophobic, but it does contain the JM-XOX corrosion inhibiting chemistry. The next installation is the Sproul WR 1200. It's an expanded perlite insulation. Like the Thermo 1200, it's a rigid insulation, slightly lower compressive and flexural strength, but unlike the Thermo 1200, the Sproul WR 1200 is considered to be hydrophobic insulation, and it also contains the JM-XOX corrosion inhibiting chemistry. The Minwell 1200, the mineral wool-based insulation, unlike the Thermo 1200 and the Sproul WR 1200, it's not a rigid insulation. While it doesn't have the same physical properties of the rigid insulations, due to its flexible nature, it's considered easier to install. It excels in areas that require acoustic performance benefits. It also is water repellent, but does not contain the JM-XOX corrosion inhibiting chemistry. The last two installations that were tested were both blanket installations, and while they're similar in application and their hydrophobic nature, the chemistries of each are very different. Blanket installations tend to be best utilized in areas where there are some space or weight constraints because of the thickness required to achieve the same thermal performance is less than with other more traditional installations. The JM Insulthin HT is a fumed silica-based insulation, while the other blanket that was tested is a silica aerogel-based insulation. So as I previously mentioned, the way that these installations were tested was using the ASTM C1617 test method. For anyone not familiar with that test method, ASTM C1617 is a standard method in the industrial insulation industry used to predict the relative mass loss corrosion rate of a material's leachable content. So first, the insulation is ground and then blended with water, and then it's set to boil to remove all of the leachables. The insulation is then filtered out, and then that leachate is dosed for 96 hours onto a carbon steel coupon that is heated for approximately, to approximately 230 degrees Fahrenheit. After the exposure, the coupons are cleaned and reweighed to determine a mass loss. The mass loss is compared to that of three standards: DI water, a 1 ppm and 5 ppm chloride solution, and that's to determine the relative corrosivity of the insulation's leachate to one of those three standards that are also tested. So for reference, these are typical performances of installations that we were testing on the 1617 test. So in the graph, all the corrosion rates are ratioed against the performance of DI water as a standard. So the 1 on the y-axis is the amount of corrosion that you would expect from testing DI water in this manner. The Thermo 1200 and the Spool WR 1200 have the XOX corrosion inhibiting chemistries, while the other materials do not, which results in their lower than DI water relative corrosivity. The droplets on the chart indicate which insulations are hydrophobic. Based on this laboratory analysis, the hydrophobicity of the insulation does not necessarily impact the relative corrosivity of the base chemistries of the insulation. There have been questions in the past over the correlation of the ASTM C1617 test to real-world performance. We have performed long-term accelerated corrosion testing through a third party and found that the relative performance of the ASTM C1617 test to be indicative of the real-world performance. And if there are questions on that testing, you can reference our previous webinars, blogs, or contact Scott directly. So these are the results of the C1617 method from our analysis. As you can see in the top row, before cleaning, that the insulations with the corrosion inhibitors, the Thermo 1200 and the Spool WR 1200, developed a surface layer after exposure, whereas the insulations without the corrosion inhibitors show more of a rust layer after exposure. The clean coupons reveal that the surface layer provided by the Thermo 1200 and the Spool WR 1200 protected the metal underneath with limited surface damage, whereas the removal of the rust layer on the insulation coupons without the corrosion inhibitor clearly showed damage to the metal surface below. And I would note that the coupons were cleaned with a hydrogen chloride solution with very non-abrasive scrubbing, as to have minimal disturbance to the base metal. This is different than the standard ASTM test method, which uses a much more abrasive scrubbing. So the insulations with the corrosion inhibitors resulted in a surface layer development that's clearly impacting the relative corrosivity of the insulations. So what is that layer then comprised of? So the surface analysis completed by the EDS found that the surface layer on the Thermo 1200 and the Spool WR 1200 coupons was comprised mostly of sodium and silicate ions. Those ions have a generally accepted reputation as limiting corrosion from chloride and fluoride ions. The insulations without the corrosion inhibitors had a surface chemistry more comprised of iron oxides or rust. The Insulthin HT had both a lower content of iron oxides and sodium silicate ions, but was comprised of other inert ions that did not function necessarily to protect the metal surface, but also did not result in significant damage to the surface. And if you recall the graph with the relative ASTM C1617 performance, the iron oxide content on each coupon correlates pretty well with those test results, as would be expected. So another common test method used for corrosion testing is the ASTM C871 test, which uses the ratio of sodium and silicate ions to determine an acceptable chloride and fluoride content of the insulation. This method uses the same extraction technique as the C1617 test. And while it's widely accepted that the leachable sodium and silicate content of an insulation can act as an inhibiting function to the corrosion caused by chloride and fluoride ions, the ions present in the JM-XOX corrosion inhibiting surface layer were similar to those generally accepted passivators via the 871 test, although the base metal in each test method is different. So based on the analysis performed, we can conclude that the corrosion inhibitors can provide a protective layer on the metal surface to decrease the corrosion potential, and that surface layer can be made up of known corrosion inhibiting chemistries. But again, a question that gets asked a lot is, how long do those corrosion inhibitors last over time? So in order to examine that, we exposed the Thermo 1200 with the XOX corrosion inhibiting chemistry to wet-dry cycling. Generally, the expectation is that the inhibitors are going to leach out over time and therefore become less effective. So we looked at two systems when we did our analysis, one with tap water and one with a 1500 ppm chloride solution. So we exposed the Thermo 1200 for 8 hours to submersion, and then followed it by 16 hours of dry out in a 400-degree oven. So we completed this wet to dry cycling approximately 40 times, and then completed the same ASTM C1617 test and EDS analysis on samples that were pulled every 10 cycles. So in the tap water analysis, we compared the new unexposed Thermo 1200 to DI water exposure and to the 4 various cycled samples. And again, in the top row of the coupons in the slide are the 4 uncleaned coupons, and then below are the cleaned coupons. So as you can see, after 40 wet-dry cycles, there's still a surface layer development on the coupons. The analysis of that layer indicates that it's still comprised mostly of sodium and silicate ions, and that the relative percentage of that doesn't change or decrease with time. Also, the clean coupons and the lower part of the slide indicate that while there may have been some decrease in the effectiveness over time, that the material still performs better than the system that was exposed to just deionized water. So in the saltwater analysis, we again compared the new unexposed Thermo 1200 to DI water exposure and the various 4 cycled samples. As with the other tests, after the 40 wet-dry cycles, there is still a significant surface layer development on the coupons. The EDS analysis of that layer again indicated that it is still comprised mostly of the sodium and silicate ions, and that, again, the relative percentage did not really decrease over time. The clean coupons show that while there was, again, a slight decrease in the effectiveness as compared to the base material, that it was still performs better than the system exposed directly to deionized water. So conclusions from the exposure testing of the XOX corrosion inhibiting chemistry found that the chemistry can provide the protective layer after exposure to both tap water and saltwater systems, and that while the effectiveness of that layer may slightly diminish over time, it still outperforms the baseline of the deionized water. All right, so now I will hand it back over to Scott to talk more about the JM XOX corrosion inhibitor.
Thanks again, Mary Beth, and thanks for that excellent discussion and information about the performance of the insulation with corrosion inhibitors. So we'll focus just a little bit more on the XOX corrosion inhibitor package that, as Mary Beth described, is integral to all of our Thermo 1200 calcium silicate and Sproul WR1200 expanded perlite insulations. It has been integral to both since 2002, so the performance has been out there for quite a bit of time already and delivering benefits to the customers who are utilizing these products. There are actually two mechanisms by which the corrosion inhibitor does help reduce the risk of corrosion and the rate at which it might occur. The first is by providing a pH buffering effect, and the second is by the formation of that silica and silicate-based coating that Mary Beth has described, and we'll talk about each of those a bit more. An important aspect to remember about the XOX corrosion inhibitor package is it is integral to the chemistry of the insulation. It is not a coating of any kind, so it is integral and throughout the entire material. It is dormant as long as the insulation remains dry, but does become activated when it is exposed to water that might get into the insulation system. So it will be there in the event that any water will get into the insulation or does get into the insulation system and provide that protection that Mary Beth described. And typically, again, as demonstrated by the information Mary Beth reviewed, those corrosion inhibiting properties will be present for the life of the installed insulation system. The XOX corrosion inhibitor package is exclusive to Johns Manville, and as I mentioned, available in both our Thermo 1200 calcium silicate and Sproul WR 1200 expanded perlite products, and it is available in each of the products in all the forms that they are available in, whether it be pipe sections, board, V-groove board. It is available in the entire product families. So the first protective mechanism that I had mentioned a moment ago was the pH buffering effect. The XOX package is slightly alkaline in nature. Typically, one of the triggers for corrosion is the introduction of an acidic or a caustic into the insulation system, in addition to the water, and that acidic chemistry then initiates the corrosion event. So with the XOX corrosion inhibitor package, when the water gets into the insulation system and brings the acidic content with it, whether it be a salt air environment, possibly downwind of maybe a coal burning power plant where you might have a high sulfuric content in the atmosphere in the area, or any other mechanism like acid rain. So any type of acidic element coming into the insulation system with the water from the outside environment is going to activate the corrosion inhibiting package in the insulation material. The pH buffering is going to try to neutralize the acidic nature of that contaminant coming in and try to keep the chemistry of the insulation system and the chemistry at the surface of the exposed metal at a neutral level, and therefore prevent the opportunity for corrosion to be initiated. And the second benefit that Mary Beth had described is the silica coating feature that the XOX corrosion inhibitor package provides. As I mentioned earlier, the package is dormant until water comes into the system, whether that be because the jacketing is damaged or any other mechanism by which water somehow worked its way into the insulation system. As that water passes over and possibly through the insulation material, it is going to pick up some of those silicate anions that are integral to the chemistry of the insulation due to the XOX package. It's going to carry those ions to the surface of the metal as it works its way through the insulation system and form that protective silica gel coating that Mary Beth described. It is also going to react with the iron compounds on the surface of the metal and form an inorganic iron silicate that will help stabilize and actually toughen that silica gel protective coating. So once that coating is formed, it is that coating that is going to provide the long-term protection that Mary Beth was describing so well. If the insulation system isn't disturbed for any reason and there's no effort made to mechanically remove that coating is going to be there providing protection for the life of your system. So if you do get a further water or corrosive ingress event later on, you'll still have that protection there. So to summarize what we've reviewed with you today, you've seen from the data that's been presented that insulation chemistry has a much stronger influence on the corrosive potential than whether or not a material is water repellent or hydrophobic, that the corrosion inhibiting package can provide a protective layer on the metal surface, thereby decreasing the potential for corrosion to occur, and that protective surface layer is made up of known corrosion inhibiting chemistries as well as other chemistries that can again reduce the opportunity for corrosion to start. And that concludes our discussion for today. I'll hand it back over to Patrick, who will go over some additional resource information with you.
Thank you, Scott, very much. I appreciate it. Nice job, guys. And just a reminder, I'm going to go through some additional resources and things that JM has to offer. And as I do that, if you have any questions, you can submit them into the Q&A box in the bottom right-hand corner of the screen. We do have a bunch of questions that come in, so we will get to as many as we can. We do have some time left, so we should be able to cover most of them. But just some additional resources for us to talk about as JM tries to continue to kind of be the full-service provider here in the industrial insulation business. The first thing we have is, we have a platform on our website that we've titled The Source, and it's really an insulation resource library. And we have one for industrial, mechanical, HVAC, and building insulation. But any webinar or ebook or blog or document or links to our products or tools is available and connected through The Source. So if you've heard about a previous webinar or you want to reference something in the past, you can find it here on this platform. It's just an insulation intel library just for our customers, engineers, and specifiers in the business. To find it, go to the industrial homepage on our website, and you can then track on the left-hand side through spec tools, tech documents, or webinars on demand, or on the right, you actually see a button that takes you directly to it. It's been up for close to 3 years now, and the amount of traffic we see and the amount of time on that site is pretty significant. So if you have someone new to your business or new in your firm and they need some education, all that information is free and readily available. And also, if you ever feel like we're missing something, please feel to reach out and contact us and ask us to put something else up there that would help you do your job easier. So. And then next, social media. Social media has gotten more and more important in today's era, and a few years back, we launched a Johns Manville Industrial Insulation LinkedIn account where we post all the latest information and news about our business moving forward, especially the industrial business. We also have a mechanical and HVAC account if that's of interest to you also. And then the next thing on social media, we're about to launch, and it's live today, a Twitter account that's framed around our education brand, Insulation Intel. While it is being run by Johns Manville, this is not going to be solely a Johns Manville account. We are going to tweet, promote, share content of everything related from insulation, of all facets of insulation. And we hope to really build a community here that we promote at trade shows and events and conferences that really talks about things that are new, exciting in the insulation space. So we would encourage you to follow us on Insulation Intel at Twitter. And then if you have something that you think is of interest to the community, please tag us and retweet us. So that way it's not just JM, sharing JM information, but it's the community as a whole sharing, industry trends and topics. It's officially live now. We're going to do a contest to grow that promotion here in the upcoming months, and you should get an email from us more about that here in the coming days. So pretty exciting to be on Twitter with Insulation Intel. And then, as we always do with all our webinars, we are going to provide you all a certificate of completion to show that you actually did attend the webinar. And as always, those will be automated and sent out to you here next week. And please, if you don't get this, let us know, and we can actually we'll send it to you. And then before we get into questions, one last thing here. Scott has presented today, and he's our Regional Technical Services Manager. And if you have any questions or comments or you need help, the one thing about JM is Mary Beth had covered, we have calcium silicate and perlite and mineral and thin blanket. We really try to be agnostic to which product we sell versus what solution is best for your business. And if you need a lunch and learn or a technical presentation, or if you have a question, Scott is your guy. So I'm going to I'm going to cut the questions here and answers and go to that, but I'm going to leave this on screen so you can write down Scott's email. But he is available to help you all. And if you want a lunch and learn presentation, you can respond in this survey and Scott will reach out to you directly. So, okay, let's turn it over to questions. I got a bunch here, so we're going to get started. And Mary Beth and Scott, I'll try to cue you guys of which one it's for. But the first question for Mary Beth is, did we test in any of our tests there, did we compare any of our testing to cellular glass versus thin blanket insulation?
So we didn't use cellular glass in any of our testing. The materials that we chose to use all play within the same temperature range, that ambient to 1200 degrees Fahrenheit, whereas the cellular glass doesn't necessarily operate in those same temperature ranges. So we were just really focusing on materials that worked all the way up to 1200 degrees. So no, we did not use any comparisons to the cellular glass.
Okay, thank you very much. And then Scott, you can take this one. Does JM's Sprule WR1200 have an additive to make it hydrophobic, or is it intrinsically hydrophobic?
Well, the perlite itself does actually have some hydrophobic properties in it, but there is also an additive as well.
Okay.
And just to add on to that, the standard for expanded perlite does require a test for water absorption after the material's been heated for about 48 hours at 600 degrees Fahrenheit. So while there is an additive, the standard does require a significant amount of hydrophobicity inherently in the product itself.
Okay.
Thank you.
And then Mary Beth, leading to the next question, does Sprule keep its hydrophobicity at 500 degrees Fahrenheit?
To a relative extent, again, because it's tested after a thermal exposure up to 600 degrees. I think it needs to retain at least 50% of its hydrophobicity after exposure.
Thank you very much. And then I'm going to stick with you. Could you elaborate a little bit on the time scale for the XOX corrosion inhibitor in terms of like years of operation? Like how long does it last?
I wish I could give you like a time frame, but I think, you know, the chemistry is really integral to the material properties itself. So theoretically, it lasts the lifetime of the system, pending any sort of significant damage or any other sort of exposure to the material itself. That being said, I mean, it really depends on how often you're going to see water intrusion. I mean, you really like to hope that your system doesn't see repetitive water intrusion, wet, dry cycling within, you know, your piping system. So I would like to say that I can give you a number of years, but I think it just really depends on that whole system and how well you can kind of maintain the integrity of your system as a whole. It's gonna last longer. The longer, the better, you know, you maintain your system. Obviously, as we saw, you know, if it's getting 40 plus wet, dry cycles, you are going to lose some effectiveness. That being said, it's never going to actually ever fully leave the insulation system.
And to expand on that a little bit, as Mary Beth described in quite a bit of detail during her presentation portion, and I mentioned in the closing section, there are two protective features to the corrosion inhibiting package, the pH buffering and that protective passivation layer, the silicate layer. Once that silicate layer is formed, it's there. So at that point, the impact of continued exposure should be greatly reduced. So it should, again, last pretty much the life of your installation.
So piggybacking on that, guys, one of the other questions here, and you kind of just addressed it, Mary Beth, but we should just clarify. someone did ask, what's the design life of thermal 1200 and spool WR 1200?
The life of the installed insulation system.
Yeah, I mean, it depends. I mean, we've seen material that's been installed for 40 years and it looks great. I've seen material that's been installed for, less than that and it, doesn't perform as well. I think it just depends on the, the quality of the installation system itself, how well it was installed to begin with, and then how well it's maintained. I mean, if you don't work to maintain your system, it's definitely not going to have the same longevity as a well-maintained system.
Understood. And then Scott, this is a question I know you addressed, but just to clarify this for the group, can the corrosion inhibitor be applied to existing in-service piping being re-insulated to inhibit further corrosion? I know you talked about this, but if you just want to reiterate that for the group.
No, absolutely. Yeah, the key is the corrosion inhibitor is not a standalone material. It is integral to the chemistry of the insulation. So to answer the question specifically, it can be applied, but it's applied by installing the insulation on that existing in-service piping with the insulation having the XOX package in it. So it's not a separate compound or material that you can apply to the piping.
Yeah, then to expand on that, is it compatible with coating systems?
Mary Beth, I'm not sure that we've done any specific testing in this regard, but I don't know of anything in the chemistry of the package that would present a situation where it would attack any kind of coating.
Yeah, unfortunately, not coatings experts. I know that there are so many different types of coatings out there. It would be very difficult to make a broad sweeping statement that, yes, it's compatible with all coating systems. Considerations would have to be, taken with probably regard to pH, if the coating is not going to be compatible with, a slightly alkaline pH. But other than that, like Scott said, it's not something that we've ever seen as an issue in the past.
Yeah, definitely a question that should be specifically asked of the manufacturer or supplier of the coatings that you would be considering.
Okay. And then Mary Beth, did we try or consider testing XOX with acidic water like pH 4?
Not that I'm aware of. My, I guess, expectation would be it'd be kind of similar to an acid-base reaction. That being said, I hope that you don't have any pH 4 material coming into contact with your insulation system, regardless of the chemistry of it. But no, I don't have any data that I can share on experience with systems like that.
Understood. And then what does a cycle or duration refer to in the testing?
So you're talking about the wet-dry cycling?
It doesn't say, but I believe, yes, we can assume that.
So a single cycle would be an 8-hour exposure to water submersion, followed by a 16-hour exposure to a 400-degree oven. So that would be one cycle. So 40 cycles would have been 40 exposures to submersion and then 40 dryouts.
Okay, thank you. And then a little bit more on the testing. Why was the temperature of 400 Fahrenheit selected for cyclic testing when most corrosion occurs between 150 and 210?
Mostly just to ensure that we fully dried out the material during the dryout time. We wanted to ensure that we didn't have any residual moisture in the material. That way we could ensure that we were getting full submersion and any sort of possible extraction of the inhibitor from the insulation itself.
Okay, thank you. And then, Scott, you can take this one. If the quality of the system deteriorates, do we need to reapply the corrosion inhibitor, which you said is integral to the product? So I guess the question is, would you need to reapply and do maintenance with replace the product?
Well, if the insulation is being used in an application where it may never get to a temperature high enough to thoroughly dry it out, and you have water that is remaining in your insulation system, then it might be a good idea to replace the material if you're seeing any degradation in it. But again, then if the temperature is that low, perlite is hydrophobic and our calcium silicate is water repellent, so both are going to resist the absorption of water anyway. So that really emphasizes the importance of having a good inspection program and looking at the integrity of your insulation materials and determining if and when material may need to be replaced.
Thank you, Scott. There are a couple of questions, and I'll just, in general, around cryogenic installations and the inhibitor. And in general, as Mary Beth said earlier, we didn't test cellular glass. And traditionally, we usually test within the temperature frame of the installations we have. But in terms of cryogenic, we do have some cryogenic offerings, and we do have some webinars on the Source platform that I mentioned earlier. And we do have some plans for some webinars coming up later this year that focus more on our cryogenic solutions versus what we covered today. A couple more questions for the team. Is the approach for preventing CUI the same for low temperature piping systems as it is for high temperature piping systems? Which goes back to the cryogenic questions.
Well, typically the risk of corrosion on low temperature systems is much lower, as has been pointed out in one of the previous questions. Most people consider the high risk corrosion zone to be that temperature range from somewhere around 50 or 60 degrees Fahrenheit up to about 300 degrees Fahrenheit. Those cyclic systems, so systems that may operate at higher temperatures than that, but cycle in and out of that corrosion zone band, those are the ones where you really have the biggest risk of corrosion under insulation. Typically, your focus on low temperature, especially cryogenic systems, is looking to prevent vapor migration through the insulation system so that you don't have airborne water vapor getting to that colder cryogenic surface. And if it's just a cold surface, condensing, and if it's a cryogenic surface, it will condense and immediately freeze. And then you have issues with the risk of the ice formation doing damage to the insulation materials. So there's not as much of a focus on CUI with cold and cryogenic systems.
Thank you, Scott. And then Mary Beth, again, at what temperature will XOX, decompose is the word they use. Thoughts on that?
So it's really good, I guess, within the operating temperature range of the insulation itself. Because it's a part of the insulation operates well within that ambient up to 1200 degrees Fahrenheit temperature. I would expect that the corrosion inhibitor would have the same operating temperature range.
Okay, thank you. And then there are a couple of questions, and just to reiterate, and yes, we will send out a recording of the webinar in an email, so you have it early to mid next week, so everyone has it. And then there are some questions around, future plans for JM Insulation Solutions, and at this time, we usually don't, unless we have something totally finalized, we usually don't talk about those things in a webinar. But there are a couple of questions around your business and stuff, and I will share those with Scott and ask him to reach out directly to you to discuss that. And as I was talking, there's one last question that came in that we can ask, and then we can end the webinar. But would there be any difference in insulation thickness of nominal insulation material and insulation material with the XOX inhibitor?
The only thing that you could really compare would be calcium silicate with and without the inhibitor, or perlite with and without the inhibitor, and in those instances the answer is no. The addition of the XOX package into both products did not change the thermal conductivity performance of either, so the thermal performance is the same. Calcium silicate and perlite have different thermal conductivities from each other, so the thickness between the two products would be different, but within the product, no, it does not have an impact.
Yeah,
Okay.
The material standards for both of those products, regardless of the chemistry of the materials themselves, still need to be met. So I would not consider there to be any differences between the material with the XOX corrosion inhibitor and the material without it.
Okay. Well, I think that's all we have for questions today. I want to thank Scott and Mary Beth for doing a great presentation. We appreciate it. We've got some positive feedback coming into the Q&A box, so thank you. And again, just to reiterate for everyone on the call, if you need some help and you want some questions, I think JM, our industrial business, offering a full line of solutions. We really strive to be agnostic and not try to sell one product and one solution for every application versus, we still have everything. So Scott is here to help you. I would encourage you to reach out to him, scott.sinclair@jm.com. And then also the resources we mentioned earlier. And if you don't get your recording of this presentation and your completion certificate next week, please reach out to us. And then keep an eye out for future webinars from JM. Thank you very much, and we'll call it a day.
Thank you, everybody.